Usually the conferences I go to in the UK and rest of Europe have quite a lot of men in grey suits talking about technology. So my name is Abraham Joseph. I wear two hats. One is Device Management Forum, and this is looking at devices that end users interface with, and typically issues around bring your own device and so on within the enterprise. The other hat is IoT Insights. So I've been looking at this area of Internet of Things, machine to machine, for some time. So I'd like to thank the organizers for the opportunity to speak at this event. It's a good starting point. Secondly, some audience participation. Who here has heard of Internet of Things? Nobody? Surely, lots of people. Okay, excellent. Who here has not heard of Internet of Things?
Take this one.
Yeah. Channel 2
Okay,
is in
okay.
English.
Okay, very good.
Right. So, a couple of quick points then. When I present on this topic, I say to people, if you landed from Mars and wondered what all the excitement was about in relation to Internet of Things, there are three things you need to remember. The first thing is basically the scale of the opportunity. People are talking about 50 billion, 60 billion, 70 billion devices being connected by 2020. It's interesting, we did an event in Shanghai in 2010, and there they were talking about 700 billion connected objects. And what do we mean by connected? It's now possible, with the prices of sensors, the prices of price of processing being so low, to start doing things like embedding floors with sensors, putting sensors into lights so you know when the lights fail. So this Internet of Things, which just about every company now has a major strategy on, is about the possibilities that are unleashed when you start connecting objects. So the first is the scale of the opportunity. The second is what I'd like to call the logic for connecting devices. So if you're an operator and you get another 10, 15, another million subscribers, the chances are a lot of these subscribers will be generating a lot of data through consuming video and so on, and your revenues will not be commensurate with the data. So it is now in your interest, and lots of people's interest, to connect machines as opposed to connect people. Let me give you an example. A strategically placed Coke machine or headphones machine at an airport, the amount of data to say I've run out of supplies is very little. The value of that data to somebody is very high. So there's a compelling logic to connect machines, and we see that just about everywhere. And the third thing is what I call genuine business transformation. So in the old days, you shuffle a few blocks in a process and you call that business transformation. These days, with just about everything being connected and it being viable to connect all kinds of crazy things, you are genuinely able to transform businesses. So that's essentially the foundations. And of course, this session is talking about IoT in terms of manufacturing. So we have a very esteemed panel. But before we do that, let me do a little sales pitch and opportunity. What we're doing at IoT Insights is basically mapping all of these verticals. So for those of you who have products or services in any of these areas, we are happy to publish your news. So let us know what's happening, and there is interest in that in just about everywhere in the world that we go. With my other hat, I'm attempting to do something similar, but to look at areas like education and so on. And I've been to a number of sessions here where education is obviously a very, very important topic. So that's about it from me. We have a very esteemed panel here, and they will be taking you through lots of different aspects of this. First of all, we have Mr. Igor Agamirzian, the CEO of RVC. Second, we have Mr. Maurizio Gattiglio, Executive Vice President, Strategic Business Development at Prima Industrie. we have Mr. Andreas Reiser, who is Mr. Cooker. He's Cooker Systems, and they do lots of exciting things in robotics and next generation automation. Martin Gitzel, Vice President, Head of Corporate Technology at Siemens. And finally, Mr. Radislav Birbraer, who is President of Solver. So, gentlemen, if we start from the beginning and in the order in which I started, and maybe just a minute or two explaining your perspective on this issue of IoT in manufacturing. Where are we today? Starting with Igor.
Thank you. Actually, I'll start from a very, say, unusual in the professional community statement. I really believe that all the new technological breakthroughs are generated not within the militaries, they are generated not within the government, they are not generated even within the big corporations, they are generated among hobbyists. The entire technological landscape we live today is a result of the club communities of the Silicon Valley of the mid-70s. The breakthrough in aviation was actually connected with a huge, tremendous interest in the communities around the aviation, creation of gliders, and so on and so on. The breakthrough in microelectronics and new generation of radio devices was connected with a huge hobbyist movement of the global radio connectivity. So, in a way, it always happens in a more or less similar way. So, when the basic technology, which is created and generated among the professionals and is growing among the large companies, is going to the level of availability and affordability that it becomes available for the communities, for the hobbyists, they completely turn off the strategic direction of the mainstream of the development. Like, say, the concept of personal computer could be created among the hobbyist community in the Silicon Valley, but it could not be created within the leading mainframe companies like IBM of that time. And the Microsoft designed its first program not for the professional use, not for the business use, not for the government use. It created it for the club of the Altair computer hobbies, the first personal computer which was available at that time. So, in a way, it's a very good point that looking for what are the current technical hobbies, we may do some predictions about what will be the next technological breakthrough. And it's more or less clear for everybody who is looking in this direction that today the mainstream in the technological hobbies movements, what is called DIY now, do-it-yourself, is actually about robotics, CNC, 3D printing, and Internet of Things. That's the huge number of the informal communities, a lot of clubs coming up to the graduate schools, and so on and so on. So I personally believe that this is a very strong designation of the potential breakthrough in this area, and yes, it is supported and connected with the analytics, with the statistical data, with the grow up on the. But the main is that it creates this. Current hobbyist community creates the new generation of engineers who will completely change the mainstream of development and make it not just affordable, but a part of life. As the pioneers, technological pioneers of the Silicon Valley in the 70s made the computing and the modern technological landscape not just a part of life, as an inevitable component of the entire life, business, work of the government and even militaries. So that's my point. I would appreciate if you could provide something to show me that I'm wrong.
Okay. Excellent.
May I have my presentation? Okay. Good afternoon, ladies and gentlemen. Now this is so maybe you, if you want to anticipate.
That's mine.
Yes. Okay.
I was wondering that you have the same title.
No, and the same slides.
Yeah.
Okay. You want to start with yours?
No, I think it's
No?
okay. They should be able to switch it. No, it's also mine. Another set of slides. That's.
Yes.
We need another set of slides from Mr. Gattiglio.
Otherwise, I think you can do your preliminary speech and.
Just see if they find it.
ICT technology is very complex and even more complex than speaking about it. Okay,
Just
thanks a
wanted
lot.
to start.
I'm representing here the European Factories of the Future Research Association. The association is a non-profit. Maybe I have to take this one. There is an interference. You hear me? Yeah? Okay. So the association is representing the industries in the European Commission. We are representing about 130 members from industries, research and technology centers, and European universities. The goal of the association is to define the strategies for the next 8 years in the Horizon 2020 program of the European Commission. The history started in 2009 in the previous program of the European Commission, which was called FP7, Framework Program 7, in which we developed 150 projects involving more than 1,000 organizations and 200 SMEs. In the Horizon 2020, the association has signed with the Commission a contract to define the strategies for funding for 1.15 billion euro of grants to industries, RTOs and universities in Europe. This strategic agenda is done in 6 domains that you can read there. I don't want to go too long on that, but what I have to say is that this is including very strongly the ICT effect on manufacturing for the future years. The strategic roadmap has been built with a particular view on SMEs. In Europe, we have approximately 24 million of SMEs, and which are 99% of the European industries. These SMEs are the possibilities to beat unemployment, which in Europe is today hitting very hard, about 26 million people without employment. About the impact of ICT in manufacturing in SMEs, I have taken this analysis from Capgemini, which is dividing the different type of approach in different companies to ICT. On these 4 segments, you see the so-called beginners. That means a company which have a very limited approach to the ICT manufacturing. The fashionists, the one which are more interested in the fashion effect of ICT. The conservatives, company which are quite conservative, but although with a strong management approach, and the real digital innovators. So the goal of the program is to bring more and more the manufacturing companies to go to the top digital innovators area. The situation today if you look at different segments of customers, of producers and the manufacturing companies, you see that the manufacturing companies are placed in the beginner area with a very low digital intensity. And the reason for that are different, probably we will discuss during the panel. Let me just conclude with this quick video. We can cut it when you want. Do you hear do you hear?
That's us.
Okay. So on this video, which has been done by one of our important members, Siemens, also represented here by Martin, there are the trends of the future of manufacturing. And I think it's well representing how the factories of the future will be in some years from now. Factories will have to face the different challenges of the world economic, of the societal challenges, and bringing the impact of ICT to all the part of life of the humans and of the workers in the industries. We see here that you will find a lot of new trends, some more European, like the aging population, the manufacturing of a one-piece flow, just part for one single need, additive manufacturing, which has a very important impact in economics, but also in new business models. With production, we will go more and more near consumption, and to the different aspects of ICT in manufacturing, machine-to-machine communication, and the Internet of Things. If I'm out of time, we can stop it here, and we can comment it afterwards. Thanks.
Okay, I speak in Russian. Добрый день, уважаемые дамы и господа.
Good afternoon, ladies and gentlemen. Let me thank the organizers of this forum that I believe to be very of high importance. And I work in KUKA Systems company. KUKA Systems is a company producing robotics, and a leading global integrator of the robots. I believe that the gentleman sitting here somehow heard of the company, and the audience as well. If not, I'll be happy to introduce the company. So the things we develop definitely are based on all new computer technologies. So without them, further development is impossible. So you saw this video for a couple of minutes, but you see it in real life. So the boundary between the future and the present is virtually non-existent. So some things from idea to execution take very little time. And so a little bit about the company. It was set up in 1898 in Augsburg, and has been in existence, has been working in the market more than 100 years, more than a century. You see the robots production, so-called, made in Germany. The company works in many directions. The main one is automobile, railway, aviation, aerospace. You see the nozzles for the rockets, and other things, many others. In this case, you see the latest robot. healthcare equipment. And jointly with Siemens, we have achieved a lot. So it's a small world. In power sector now, which is extremely important, and then there are many industries that are absolutely impossible without ICT. So whatever you model in virtual environment will then later be created physically. So this was some general information about our company. Some things actually look a little bit fantastic, like science fiction. But what you saw is absolutely real. And then, next, I would like to show you my presentation. The company has been in existence for over a century, and in 1973 we created the first robot, which means that it would be impossible without any computer technologies, because the handling, the automation system can only be done through computers. And so we have created the new generation. So unlike the conventional robot, it can work hand in hand with a human being. I believe this is a breakthrough. So the company has KUKA, consists of three parts, three chapters: KUKA robotics, KUKA lightweight, that a robot that can work together with a human being, and then KUKA systems, which is an integrator. And I trust, so the company has turnover about 2 billion euros, which is not very important, but we produce robots, different configurations of robot and KUKA labs for the new developments. So today it is a breakthrough, as they can cooperate with a human being. They can do something together which used to be impossible. And KUKA Systems, which is a leading integrator. And so how does it dovetail with our topic? So recently we made a big project in Russia, a railway car manufacturing plant, and let me show you how it all started. It will take a minute of your time. Can I have the second video, please? So before the project was kicked off, we made an immense quantity of homework. So the company, it was not a greenfield operation. There was a company, but we needed to upgrade it, modernize. So we used our software to make a complete simulation of the plant. It's not a cartoon. It's a simulation of a real facility with the technologies that we possess in real time. So it was a very important tool for designing a plant, a factory. So it's a long video, so we shall stop here, and I will show you another small video, so with the final result, number 3. So indeed, it was a project, a successful project that was carried out in near St. Petersburg, and that it works, and it can compete with any global company. So the automation level is unprecedented. No one can come close to it.
Здесь вы видите производство торцевых стен.
Now what you see would be the back walls for a freight car, for a cargo car. That's a welding station for the side walls of a rail car. And all these operations were modeled and simulated using our systems. Since we are pretty much short in time, I'll stop here and I'll thank you for your attention.
Okay. So the micro. Okay. The presentation, please. Do you hear me? Yeah. Okay. Good. Okay. No, it's not working. Okay. Ladies and gentlemen, thanks for the opportunity to talk about the future of manufacturing, or let's say the way how we from Siemens' point of view see it. There were already 2 links to Siemens today, which is good. What I like. And it was, let's say, on the one hand, it's about the technology we are providing for manufacturing, means industry automation and related software tools and environments. And on the other hand, certainly Siemens is a big manufacturer itself also. That means we're producing technology, but we're also applying the technology. Industry, it's actually German wording there, sorry. Industry 4.0 is what we call, let's say, adapting, or the next wave of introducing state-of-the-art IT technology into the manufacturing process. Okay, if you look at the manufacturing globally, it's getting more and more important all around the world. That's clear. On the one hand, let's say in Germany, we have the high-tech strategy, projects for future industry 4.0 and smart services world. That means using the data which is available and interpret the data, derive from the data more knowledge, and do prediction forecasting for next steps. Then in US, we have a manufacturing renaissance, at least as we see it. We have formation of a national network of manufacturing innovation, research center, digital manufacturing and design innovation. So that means what in former days we looked always to Asia, now we look back, and even, let's say, manufacturing was what was in former days done in Asia is now doing again in US, is now being done again in US. On the other hand, in Asia, if you look to China, we have a reform of industrial policy, focus on IT, integration industrial processes. That means quite a wave of modernization. And on the other hand, also in addition, energy efficiency legislation. So not only to be able to manufacture, but also to be able to do it in an energy efficient way. Governments are launching initiatives to strengthen industry. I think that is, let's say, what we see all over the globe. Certainly Germany, US, but also what we see here as an example of Asia. There are other areas. If you look to Russia, there are initiatives to strengthen the industry, and it's clear that it goes also in this direction. So challenges for industry are growing worldwide, increasing competitiveness. That means efficiency, shorten time to market, enhance flexibility. And if you look, let's say, increase efficiency means energy you need for this and the resources you need for this. If you look at the time to market, means shorter innovation cycles, more complex products, and larger data volumes, and hence flexibility. It's not only the mass production, it has to be individualized. So we had also examples here, also only one piece is manufactured, for example. Then probably additive manufacturing would be the right way forward, especially when you are in developing a process. And volatile markets, high productivity. Let's say manufacturing, what we see is changing faster than ever before. In former days, the cycles or the development cycles in technology for manufacturing was much more conservative and slower. Now it's very fast, and I would like to focus on the individualization. Real and virtual worlds are converging. So on the one hand, you have all the tools or the IT environment to do development virtually, to do simulations, and on the other hand, you have the real world when it has to be manufactured, and that is thanks to innovative software and powerful hardware. So we have more opportunities and more the power of the hardware tools, the hardware platforms, hardware tools, and then the software platforms and the software tools. So on the one hand, design and virtual production, we call it production planning, product design, and on the other hand, the real production engineering and production execution. That forms what we call a digital enterprise platform, followed by respective services. In Siemens, we have two main lines here. One is a PLM, product lifecycle management. The other one is a totally integrated automation. If you then look, let's say, the entire product development production process, we, let's say, look at the 5 steps here we have made. We have the product design, production planning, production engineering, production execution, and then the services. And all of these steps, on the one side, we have, let's say, virtual components. On the other hand, we certainly have real components. So we verify design and manufacturing processes virtually and validate and optimize the real production then. So let's take a glimpse into this. For example, if you look at the Zeod race car, was a development of high-performance cars with PLM software. That means our, let's say, design environment, and the challenge here was extremely short development and production time. So we had very little time to design it and then do a short development and then have also, let's say, fast availability means production also available right away. We did digital simulation, verification accelerate the optimization process. So it's, let's say, you have also always optimization loops. Let's say, to come back to the previous step, if you have the right tooling available in terms of virtual design and virtual development, and on the other hand, let's say, a close connection to the production line, then you are much faster than before. So other example, simulation of dip coding system for automotive industry. So that is, let's say, a dip coding system developed by us, and it's simulation of the system to determine plant geometry and throughput. If I say developed by us, we have developed the software tools that Eisenmann can do it. So we have enabled Eisenmann to come up with a dip coding system, and the important thing is it's first done in a virtual environment. And you have complex dynamics thanks to 3 axes for horizontal, lift, rotation, movement, while accounting for acceleration, delay, and carryover. That means it's a quite, let's say, a complex system here. And if we look at it, how it works, it should work now. Oh, okay, so that is how it works. And that is a simulation how the real system will then work. That means we have the tool environment, we have to model the automation, and at the end be implemented by Eisenmann in the real factory. If we then go, let's say, to factory itself, we have Comos walk inside, a powerful 3D visualization of process plant. So to understand, let's say, all the engineering data in all stages of the plant life cycle, we have direct access to current plant information and virtual reality models and enhanced operational safety for all persons involved. So how does this work? Does not work? It works. Okay, so now we are, let's say, walking here through the plant and can, let's say, grab more, can look at individual installations, can grab also more information. We will see, here there is, let's say, some status data we can look at, and also there is a permission available to access this machine. And then we move on and look at, let's say, a pump that is our interest because there was a fault indicated by this pump. So we don't do it again. So another example for total integrated automation, the BMW plant in Shanghai. We did here a factory automation in a way which is a solution for efficiency and energy savings. And that was again, let's say, designed virtually, then certainly implemented, and Siemens supports automotive manufacturers in China to get to the next level of production of manufacturing quality. I took this example because, let's say, this forum here is under the cooperation of Russia and China, and we have very, very good experience here in China to provide factory automation. And I would be happy if, let's say, we could also make a success story in Russia using newest technologies. If we go further on, from vision to reality, shaping the future of manufacturing, that is, let's say, if we look at the stages of evolution in manufacturing yesterday, local automation technology, so that means local isolated systems. Today, communication-based automation, so the isolated systems are communicating. Tomorrow, optimization of the entire production process with innovative software systems, and thereafter, organization and optimization of production through cyber-physical systems. You will see, or you will hear this term much more often in the future. We had the example, I think, with sensors here. So there's tons of sensors, or let's say bazillions of sensors in the factory in future, which communicate and provide data which can be evaluated and then optimize the production process. FEP's key elements: fusion of virtual and real world, cyber-physical system and dynamic production networks. That means flexible value chains with information available in real time across company boundaries. That is important, this availability of information and the usage of information for optimization and for dynamic configuration. Communication requirements, Industry 3.0. Let's say, how do we go to 4.0? I do not want to go into detail. I think the spirit or the flavor came already across. But what I would like to say also, it's important, we had, I think, examples, what is the profile of the future employee, or how does the profile of the employee also changes with evolution of manufacturing. And that is what you see here, structure of previous training in Germany, as an example for Siemens. Since we have a long history, we can talk about it. In 1970, 56 people had no training or none in the field of the work, and only 34% apprenticeship or technical school, and then 10% college or university. What you see in 2013, let's say the picture is different, much more qualification needed, more qualified workers needed, also what is traditionally called a blue-collar worker. So modern production requires higher qualification, more skills, and yeah, thank you.
Добрый день, уважаемые коллеги, слышно?
Good afternoon, dear colleagues. I hope you can hear me quite well. It is with great pleasure that I accepted the invitation to take part in this roundtable to discuss digital manufacturing, the shaping of it in future, and the strategy of such digital manufacturing. Because I think that in such a good company, we have something to share between us. I'm appreciative of the first speaker, Igor, who said that probably the best innovations are born within small communities or clubs, and they are then advanced to a new level by big industrial companies. And this was actually the idea that was also proven and demonstrated by our other panelists who demonstrated all these aspects of automation that prevail in such big companies. Our company is an engineering consulting company. And this is exactly this small hobby club, which is 21 years old now. And our company includes over 300 engineers. And what we do is that we actually are dealing with innovative developments, trying to implement them in some serious big projects in machine building. And I think that all the big names in machine building in Russia are our customers, and we have something to really be proud of. We have over 200 individual projects implemented for the machine building companies. And indeed, this is a club, this is a platform where ideas are born and are implemented. There are green fields and brown fields. And now we are clear that there's a general trend in manufacturing and, of course, in digital manufacturing. Take a look at the technologies that prevail in the digital manufacturing. CNC, for example, M2M, machine-to-machine, MOT, the Internet of Things. You also watched the video that my colleagues showed, but you didn't see any people there. Beautiful videos, but without people. And I think that the only limitation or constraint that limits the capacity of digital manufacturing would be people. These are not mannequins or something, but these are people. And unless we realize that we have to change the paradigm, and instead of trying to catch up with the machines and automation, you need to automate the human being, then we would fail. And probably we need to robotize or automate the human being. Is it possible? Yes. And we now have not CNC, but HNC, human numerical control. And they're trying to get a patent for this technology. You can talk about industrial navigators of sorts. And I have a few slides to show to you. Yes, I see that. That's the right slide. What is this navigator? Just like a GPS navigator in your car, this is a map with prompts and online control. In our interpretation, this is sort of a software hardware-based system to automate the operations of the operator during manufacturing. So it shouldn't all necessarily be machine building, but also we're talking about that this navigator would be using some human-to-machine algorithm. You need to write up this map and algorithm. Social dimension, of course, this is positive competition. You need to train a group of people who are proud of their trade, people who are using such navigators and who are objects of this HNC technology. We're talking about people who would be thinking about their jobs not in terms of hours, but about performance, in terms of their performance. And of course, for the owners of a business, you would need to somehow combine automated machines and automated human beings. And you want to be sure that people are using the most up-to-date technologies. Developers can share their ideas and expertise and develop continuously, and operators can be using some control points to work better. So the operator is not alone with his or her challenges, and we think that harmonizing such digital manufacturing and HNC, I think that's the summit of what can be done. This is one of the prototypes of our HNC navigator, and the relationships between the human being and machines is a key, and because machines can be ideal to execute a command. A human being is a creative being, but also makes mistakes that the machine cannot avoid complying with. But having an HNC, we can have the biggest rapprochement between the human being and the machine. This is some regulatory basis and control points for the operator, online monitoring, performance checks through the light indicators, light checks, green, yellow, red, and then the human being can actually real-time have information about whether he or she is going away from the correct manufacturing or production process. So as soon as you pass through a control point, the operator is reported by how much the operator is away from the final point. And then it, of course, can statistically collect information and monitor whether the operator is automated enough, whether such menial operations are automated, because really what you get is some expert assessment and description of what is being done. This is the interface of this industrial navigator, of this HNC navigate. You can go through from the monitoring area to some description area, some graphical elements that would prompt to the operator the essence and requirements beyond each step. Some examples of how this can be done in practice, and of course what is important here, it would be to have some buffers. Ilyahu Goldberg, who unfortunately is now deceased, he actually presented an idea of manufacturing not as very exact processes to arrive to a final point, but basically as a series, as a sequence of buffers for the operator who is doing some manual work at each particular point would know that the operator would reach the final point at this or that time. And if you are in the middle of the process and you are late and you have red light, then you know that you need to hurry up. On the green light is okay. If you are talking about a black light, then you really need to rush. Now, this is like a game, and the presentation for the human being, whether you need to accelerate or you're okay in your movement towards the final point or the final stage of the process. And how do you really make this navigate? It can be done through some multimedia functionalities. It could be photos or videos, all such multimedia options are put into the navigate. You'd have the process map that is your basically guide for the operator or for the assemblyman Or maybe sometimes you can actually give this navigator to the designer for him to test whether the design that he's making is feasible. Now, this is the navigator that we're talking about. This is the navigator for some mass production, stable support to innovative solutions. It also can provide analytics and statistical information to the managers. And the use of such navigators is a guarantee of the speed and promptness of the execution phase of the production process, regardless of the qualifications. One of the examples when you actually can have a better throughput of the you can actually achieve a threefold increase in the throughput of the manufacturing process in some cases. Thank you.
Sorry, as you can see, I've just failed the initiative test. Okay, so in addition to our expert panel, we have a couple of experts in the audience. And at this stage, I'd just like to get their input before we move back to the panel. So our first expert is Mr. Nicolas Remy of Renault. We've heard quite a lot from the panel about the future of automation. My question to you is, are they delivering what you are looking for? Are they on track? Are you looking for more?
Thank you for the question. My name is Nicolas Remise. I'm the Director for Strategy in Russia and in Eurasia for Renault Corporation. So I've seen in the first couple of slides by Mr. Gattiglio in particular that manufacturing we're still at the beginner's level. But through all the presentation, I felt that I could recognize myself or my company in many of these areas, actually. So we started for customers to reduce the lead time for development. And that was necessary to reduce our costs because our customers expect more and more features in our cars. And they don't want to spend too much on cars. So we've used, for example, the prototyping, virtual reality, the design of our plants, always automatized, so we can reduce lead times, we can reduce our testing. This has been done. And in this, I believe, the delivery has been okay with our partners. We use the virtual reality throughout all our processes, down to sales level. What is now at stake for us is we include also all this data in our products. And we can see there are many changes in our industry with some newcomers, let's say companies from the IT world that want to enter the automotive business. Here, we are preparing for the change of the paradigm of our industry, which is not providing cars, it's providing mobility and services. So in this respect, what we can see is some outside companies, I would say, IT companies, which you're used to, the one that show you blue screens when it's not working, are not fully understanding what our customers expect. And this is where we expect more work together with some IT companies, not overtaking our job, which we know our customers, they don't know. And they have the habit to react in patches, but no customer will ever accept a patch on his car because you're playing with the safety, with the life of customers.
Thank you. Well, our other expert is out of the room for the minute, so let's turn back to our expert panel.
may I react just to the last
Yes, absolutely.
statement? I'm actually very sorry. You touch a very important part of the. First of all, I really think that the entire manufacturing is now in the very, very beginning of the long path. And you can compare it with the computing in the beginning of 80s when the mainframes were just started to be replaced by the mini computers and personal computers. That's my view of that. And we hardly cannot even predict today how the landscape will look like in 20-25 years from now. And your last statement about the patches and updates. I'm sorry, but today already Tesla is doing that. The Tesla cars are getting internet updates online, and in the morning you can have a different car from that you left in your garage yesterday night. Я перейду на русский, хотел бы сказать еще несколько слов.
Just a few words more. This example, I think, is a brilliant demonstration of the fact how the digital world is making an impact on the physical world. It's like a breakthrough, as was nicely mentioned by our colleague from Siemens, that we're talking about a cross-section between the digital world and the physical, the real world, where manufacturing is done. And realistically speaking, manufacturing, and not only manufacturing, but also the management of all the processes that define our lives, from logistics, transportation to utilities and housing and power generation. And this is all basically captured by algorithms. And a car today is not just some piece of metal, but it is also a platform that is important because it has some algorithm of mobility. A modern car is quite different from the cars that was made 50 years ago, but different not by the engine, by the system of fuel injection, which actually optimizes the consumption of fuel and generation of power.
All the modern industrial environment is actually formed by the algorithm. So when what is inevitable, what the traditional physical objects will be updated, and just like software at your computers, is absolutely inevitable, unavoidable, and you have to comply and go with the trend, not against it, because any attempt to go against the wind will only incur additional losses, but will give you the same result anyway.
Yes, I have to thanks Nicolas Remis for the question, but I would like to point out the fact. The digitalization of manufacturing is not only a matter of very large companies, because we can have the impression here that the digitalization, ICT, Internet of Things, M2M is something which is applying to manufacturing of cars or aerospace of very, very important and manufacturing of large numbers of equipments altogether. The expectations are exactly opposite. We expect ICT will play an important role for SMEs. So we have seen in the first presentation some elements that I would like to point out. First one is collaborative robots. Collaborative robots are done to work with the humans in production of small quantities, even single flow piece. And also Radislav, this idea of human NC. So a product which is done to help the humans to make their work, to help in that. So this is something that we have clearly to focus, that the challenge is there, and to do to win this challenge, industry has also to probably overcome some models that are today in order to allow to SMEs, to medium enterprise, to access, for example, to do the simulation tool. If you are going to buy a simulation tool like this one, will probably cost you 100,000 euros per year of license. Most of the small companies will not able to afford this type of cost. Then cloud model can give an answer to that. So probably I will ask Martin to give some hints about this, because we have to go over the matter of buying a license, paying it a lot of money, and use it maybe once per year. Small and medium enterprise cannot afford that. So in the cloud, they can just buy and pay what they use. They can use simulation, they can use these tools for a short time and pay just for that. Thank you.
Okay, we have quite a lot of ground to cover, so what I'd like to do now is to move on to the topic of investment. And I'll start with you two gentlemen again for two reasons. One is, Igor, you're responsible for funds of funds. So you're making bets on, you know, where the technology is going and where Russia ought to be investing. And Maurizio is very intimately involved with the European Framework Program and Horizon 2020. So very quickly, gentlemen, where ought we to invest? And are we doing the right things? Where is investment needed and where should it go? And then I'll pass it on to the other two gentlemen.
Спасибо. Я на самом деле хочу начать с того, что полностью присоединиться.
So, I would like to join completely what Mr. Gattiglio said. I trust that development of digital technologies and deployment of them in mass production will lead to the explosion of so-called boutique model, when you can do customized product for specific needs of individual and customer, and its small production will be as profitable as today's mass production. In long-term perspective, the existing trend of automation of production facilities most probably over the next decades will completely kill mass production in the way we are used to see it, to have it. And in fact, this mass production, which is a modern standard, is quite new. 100 years ago, it was non-existent as a concept. And for instance, shoe manufacturing, footwear manufacturing was absolutely individual. It was footwear was made to order. Today, there are startup companies that use the new technological base and made footwear for each individual foot, which is going to be comfortable by default. And most probably, in 20 years, we shall not have any shoe factories, but footwear will be produced in a store or at home, the way we print documents today at our laser printers. And in another, or 20 years ago, to print a document, we needed to carry it to a specialized shop or a publishing house, and the quality and economics of printing today, in fact, is much better than 40 years ago it was in a printing house. So this is a general consideration. So today it would be irrational to invest in the generation of technologies that's going to be pushed out by the new technologies. So today it's promising to invest in something that's going to be normal for the technological landscape tomorrow or the day after tomorrow, because someone has already invested in it. So this is no doubt is a totally different model. I agree that the licensed software model will die a natural death. I'm not convinced that it's going to be replaced by cloud, because today a more popular trend is open source for amateur applications, and those and Internet of Things professionals know that Arduino phenomena, which is absolutely free of charge and is an open source hardware, and the largest automation communities gravitate to it, does not actually has no place for licensing or cloud model. By definition, it's an open source system, and it creates the new ecosystem of approaches and understanding the importance of a software stack for production, like Siemens Teamcenter, which is a leader today. I see at the same time a totally different requirement that Siemens or no other corporation can deliver, like PLM Lite. No one offers PLM Lite, and this is exactly the sector, the niche that will be taken by those, captured by those communities.
For all the budding entrepreneurs in the audience, which areas should they be looking to attract funding? And over to you, Maurizio.
I have first to thank Igor, because I fully agree with his speech and the point he focused. First, things that the new factories and then the new companies have to focus is that, and I again agree with Igor, mass production is something which is no more in and is dead. And this is substituted by mass customization. Mm-hmm. And the example that Igor did on shoes is very appropriate. Adidas, for example, has brought back production in Germany of shoes from China, because today you can select on internet the type of shoes you would like, the color, how it's done. And this was done before, and the shoes was produced in China, and the delivery time was 3 to 4 weeks. And this was not acceptable by the customers of Adidas, and now they moved the production nearby. So in general, entrepreneurship has to look at the fact that manufacturing is going near consumption. This is a very clear trend. Then another point that Igor put on the table, I think is also very important, is the matter of the open platforms. In general, the platforms have always been a weakness for European and also Russian manufacturing of ICT. The suspect is that for the platforms of ICT manufacturing of the future will be either Google or maybe very proprietary solution like Siemens solution that will allow to have a unique solution from the PLM to the management of the manufacturing to the end of life to all the phases of production, but probably an open platforms based on standard will help to grow a lot of industries and companies behind the big trend of ICT for manufacturing.
Okay, so Andreas, without giving any trade secrets away, obviously, what are the main areas that Cooker is investing in going forward in the context of what we're currently hearing? should I be looking forward to a little cooker at home, for example, making things for me in 10 years?
Но на самом деле компания Кука...
In fact, our company produces generally industrial robots. We have not yet entered the domain of developing robots for a household. But I believe this may be the next step, because we can use and convert many technologies that we possess and transfer them to the new home appliance robots that will be used in other areas. As for the investment, I will agree with you completely. Once we compare the first robot that we made in 1973 and current robots, so the software and the hardware probably cannot be expressed in mass or volume, but it's important. The development goes on a qualitative scale. So have I answered your question?
Is in the relatively unique position, I guess, of spanning just about everything from industrial to super consumer. So where is Siemens investing if we were to look, I don't know, 10 years out? Should I be looking for a little Siemens to be doing my manufacturing at home?
Okay, I mean, we are not, let's say, active in any field, in all fields, but in many fields. That is clear. Consumer electronics is not on our roadmap anymore. Nevertheless, if you look at manufacturing or evolution of manufacturing, then it's probably the most important area we see at the moment is additive manufacturing. And that means going to small-scale series manufacturing. That is one thing. And then, let's say, printing spare parts to have this facilitated, and also support the development process, the rapid prototyping. I mean, additive manufacturing, we are always talking about, let's say, if there's small-scale series, or if there is something like a very complicated part, which is complicated to manufacture, perhaps you can print it. But it's also about the development process, to speed up the development process in terms of rapid prototyping. That is what we see, that if you look again at the holistic world of manufacturing, starting from the design to at the end, the quality assurance or the service even. So additive manufacturing is something we are strongly looking in, and it's not there as many might, let's say, give the impression, but within, let's say, a couple of years, perhaps 5, 6, 7, 8 years, we will see big steps there.
I have a quick comment it's better like this, okay? I have a quick comment. In general, we have to say that the focus has to be on flexible and technology suitable for low quantities. Also, if we look at additive manufacturing is not a new technology. My company was doing additive manufacturing 20 years ago for Boeing, and we were calling it laser sintering. And also on plastic at that time was called rapid prototyping. In general, all the technology which today are suitable for low quantities, also for prototyping, these can become the technologies of the future. So mass customization is a very important trend.
Yeah, and the thing I want to add, most very important thing is we had here the small and medium enterprises. That means the technology has to be affordable also. That is the point. If you look to automotive industry, the big ones, Daimler, they're using certainly additive manufacturing for a longer time already. But let's say we are looking here also at the SMEs.
Можно я в связи с этим совсем короткий комментарий?
So I have a short comment in view of that. Very few know that all the modern 3D printers use the J-code technology developed in early 60s of the last century. And the difference between a piece of equipment 50 years old and the modern piece of equipment, which is CNC affordable and loved by the small businesses. The difference is not in the machine tool, not in the mechanics, but it's the computation capacity and the algorithm of the computers that has changed. In order to produce something that this thing can do 50 years ago, you required a mainframe that would take the whole room like this. And today this little tablet can do, and it was 1,000 times more expensive than the equipment that it managed. And now it's a fraction of the cost. That's the revolution, not in the machine building, not in the machines, not in the hardware, but the software. The capacity, the computation capacity is the revolution. As actually we have been talking on very interesting topics, I would like to probably kind of draw a line. I think that we really see a very clear-cut trend for customization when we abandon mass production and try to produce in small series. 10 years ago, 3D printers were kind of prototypes and science fiction, and today it's digital production of small consignments, but the higher is customization level, the higher customization level, the more adjustment we have to make. And this lean production that we actually are talking, unfortunately in Russia, this lean manufacturing, lean production is poorly interpreted in Russia. But again, another issue is adjusting a person to the new trend, to the new manufacture. We need to create a controller of human management, managing a person. So with the level of gadget and computerization, a person plays, uses a phone. Children sleep with their cell phones. And we feel that we need to make another little step, and we can get a human controller. So we need to bring the process to the working place, get the feedback, understand how efficiently a person is using this instruction and management. As soon as we create this kind of manufacturing structure, we shall go away. We shall eliminate the issues of powerful ERP systems that provide so cumbersome instruction that are difficult to follow. And there is too much room for human errors, for the human factors. And so harmonization of digital management activity and the human being activity is going to be the next trend. So I would like to comment and ask a question. So, about a kind of interface, do you think that general automation and robotization of manufacturing will actually pass your trend, overtake? So we shall be able to produce anything without any human intervention. I agree, it is possible, but is it for good or forever or for a while? Yes, I think you are right. Look, when we say that we trust our manufacturing to the machines, respecting the robots, but we still say that we talk about the mass production, but when we cannot take a human being completely away from the manufacturing process. Even a simple operator who will just reset the machine, he's still needed. And what a person is a black box. Only he knows how to make it within 5 minutes. You take the other guy and he will come and say, no, I can only do it within 8 minutes. And the manager will have to agree because no one knows how long does it actually take. So as soon as we stop considering those manual action like a black box and try to control it, and an expert will tell you how to do this manual performance, we shall open the new era of manufacturing. Well, in fact, it sounds strange, but I will support you because I saw a live example when your approach was really implemented with the use of software of your colleague on the right. With my own eyes, I saw a manufacturing process where a component of Siemens tech for cutting composite materials, a very complicated strategic component was cut, but with a very small series. So this composite material, people had to handle it manually just because it was not economically viable to use a robot here, because we only make 10 pieces a year of that kind. So people do it manually. So again, speaking about the boutique customized manufacturing, people who will have to follow the computer's instruction at such customized small series production, in a way, will still be required, still be needed, but it's not going to be a creative thing. So I don't like the idea of controlling a man through a software, but as in a creative process, just guided by a computer system in order to optimize is absolutely good and feasible. And we have many cases when, for instance, some robots produce components, but once the quantity is small, no one is going to automate it if you need to produce 10 pieces. So they will decide it. They will design it in CAD and then produce through laser burning and then assemble manually from components. That's how it happens now. And unless you make millions of such boards or chips, but if you have to make 2 or 3, this is economically viable. And definitely we are talking rather about prototypes and about small unique production. But the general trend is that at any mass production it will be completely automated at production facilities. And what is important is that the economic center of adding value will kind of shift into the engineering and design. So the operator of 21st century will not be kind of stretching the composite fabric in order to plastify or make or cut out a detail, but the one who will actually design the cutting of the fabric to get a new shape, and the person who will draw this shape considering hydrodynamics, and so it's the math that's going to rule. It's not in the hardware, it's not in the processes, it's not in the hands of the operator, but it starts with the math and algorithm.
Questions from the floor. Okay, one come back.
I still have one. Sorry. Sorry that I couldn't get my point across, at least to Mr. Agamirzian. We are not resisting the change in the industry. We know it's coming. We are prepared to it. We are working with the industry. I've got two questions that I would like the panelists to address. What about data privacy? Who is protecting the data when it's exchanged? And the second one, regarding the manufacturing in small scale, close to the customer, we know it's coming. What about product liability? And who is responsible for it?
Mm-hmm. Okay, thank you. Any other quick points which the panel can address? Okay, very quickly. Let's start at this end.
Можно еще раз повторить вопрос? Я немножко...
So, can you repeat it again? I didn't really grasp it. So, the product liability, do you mean who will... So, if someone produces a small quantity of products, who is going to be liable for the quantity, for the quality standard, safety, right? Mm-hmm. Unfortunately, I will have a standard answer. Is it going to be a customized or mass product? In any case, the one who designed it will be liable, and then the manager who controls the production will again be liable and responsible. I don't think there will be anything new here.
You raised a very important question, but probably we need another panel for that.
Right.
Because the legal issues which are coming out in a new world in which we will have not physical goods traveling, but data, it's a very important issue. So liability is important, protection is important, safety of the data is very important. So I don't know if there is already a panel for that, but I know that a lot of legal stakeholders are working on these issues, because this is a new economy which will bring new challenges also for the legals.
Yeah, as a representative of the organizers, I can promise that we'll do the best to include such topic in the next year discussion, because that's a really important question. Frankly, the modern production technologies gives a real opportunity, for example, to create the viruses which are not the virtual computer viruses, but which are the real physical world ones. And we'll have all the problems which are now just around the information security on the internet, we'll have in our physical world. It's absolutely inevitable.
Yeah, I think that is clear. With the data protection is very important. I mean, that is on the one side you want to protect their own data and the process data, that it's not, let's say, read by others. On the other hand, you want to avoid certainly injection of malfunctioning code or whatever. I mean, this problem starts in the moment you connect systems. That is clear, and it certainly gets to higher levels when it's not only a connected system, when it's, let's say, entire virtual system with complex data. The point is here, let's say, we have examples from internet security, and I would expect that, let's say, most rigorous mechanisms are also applied there. Beyond, let's say, it cannot go, that is clear. But it's a legal issue. At the end, question who is liable. Another thing with the, let's say, with small scale series, or let's say additive manufacturing, for example, if you grow a spare part out of, let's say, raw material, who is responsible, what is the liability at the end? I think that is a very big open field so far. What we are certainly focusing on is additive manufacturing, first of all, not for mission-critical parts. That is one thing. And for, let's say, small parts, which are also where long life is not expected. For example, if you have in a train some plastic parts in the compartment, that is where we can do, where we apply advanced manufacturing, but we would never apply this at the moment to mission-critical parts. That is clear. So that's a long way to go, and therefore I would also say additive manufacturing. People are very, let's say, euphorious on this, but I would say it's a long way to go. Clear.
Okay, thank you. The final comment we leave to Andreas.
Я думаю,
I think that indeed this is a big challenge. I can give you a parallel example. In developing our new robot, LWR, lightweight robot, which can work without any limitations on the human part, we also had to take a long way in developing piles and heaps of various documentations before we actually had permission to have the robot to work with a human being. So if you think about this way, you would see more challenges, even more challenges.
Ladies and gentlemen, you've been very patient, but also very quiet. I'd like to thank the panel very much for their contribution and also our experts in the audience. So thank you all very much.